Welcome back to our Zoom lecture for today. We're going to talk about one question for the last half of the last segment. And that question is, why does methyl cyclohexane spend about 20% of its time in this chair and about 80% of the time in this chair? And I got other questions along the way too. What happened to the methyl group when we went from one chair to the other? And I need two parts to your answer every time. The questions are, did the methyl group stay up or stay down, or did it go from up to down? And the answer to that is pretty simple. It's up here, and it's still up here. When I say up, I mean above horizontal. Here's horizontal. It's above horizontal there. Here's horizontal. Right through the carbon is horizontal. It's above it. So when you go from one chair to the other, all groups that used to be up are still up. And you can use the H as an example too. Here it's down and here it's down. So everything that was up stays up. Everything that was down stays down. The other question is does axial switch to equatorial, or does axial stay axial? And that question is answered in purple. It's up axial in the first one. And because you did sigma rotations, it is now up equatorial. So you got to remember, something stays the same, and that is the direction of the bond. Up stayed up, and something changes. All axials become equatorials. Let's do the same discussion for the hydrogen that I drew. Hydrogen's down. It stayed down. That follows the methyl argument. The equatorial H here is now axial. So equatorial becomes axial. These two facts always hold true. Okay, the main question still remains. Why does the molecule spend 20% of its time like this and a whopping roughly 80% of its time like this? I'm going to show you something on the bottom two copies of the top molecules. I'm going to draw the axial H's that are there and there. Those are axial H's that are 2 carbons away from CH3. So we're not talking about axial H's on the adjacent carbon. We're talking about axial H's on 2 carbons away. They are relatively close to the methyl. This is a negative interaction that it reminds me of eclipsing. But remember, eclipsing is on adjacent carbons. These are just close in space on adjacent to the adjacent carbons. And there's a repulsion here because those are the 2 closest things in this molecule, this CH3 and this H, and they're equal distance between this CH3 and this H. And this negative interaction is a repulsion. That's another way to say it. Repulsion is called, we're ready for it, 1,3 diaxial repulsion. So those are the closest things in these 2 molecules, the axials that are 2 carbons away from each other. Remember, a methyl's a lot bigger than an H. So I don't care about other H's in this molecule. I care about the big fat methyl. And when we go from this chair to the other chair, it's going to spend a lot more time over there than here. When you're equatorial, tor, EQ here, AX here. Just remember we had them up here, EQ and AX. When equatorial, there is no 1,3-diaxial. I want you to get used to saying this phrase, 1,3-diaxial repulsion. If you strategically place it in the correct portion of your exam, you get 2 points just for saying 1,3-diaxial repulsion. And remember, it's the big group you care about. Please don't ever say there's no 1,3-diaxial repulsion. In normal cyclohexane, there's a diaxial repulsion between these two H's. There's a diaxial repulsion between these two H's. There's a diaxial repulsion between this straight down and this straight down, and this straight down and this straight down. So don't tell me there's no diaxial repulsion. But it's worse to have a larger group with diaxial repulsion than H's. I hope that makes sense. Okay. Now, mini homework assignment here is for you to talk about these words here. I'm going to type them out here. Mini homework assignment. Steric hindrance. We have talked about steric hindrance without using those words today. And we talked about two forms of steric hindrance. 48's big. One 1,3-diaxial repulsion is one type of steric hindrance. Okay, why are you doing this to me? My computer's ignoring me. I guess I gotta go off. Then I can go over here. I did not know that was gonna happen. What? I may have to take a little breather here. Save. And I'm gonna leave you a verbal. I may have to, there we go. Got something there. Could be a pen thing, huh? And eclipsing. And eclipsing are our first two forms of steric hindrance. Steric means close in space. Hindrance means things are almost or very close to bumping into each other. Okay, so today we've discussed steric hindrance at length, and we just finally put words to it. And we're going to finish today by doing 2 chairs, if we're lucky, with 2 groups on them. Let me see what I get here. I might be doing a lot of erasing. Yeah, apparently. Let's see what I need here. Won't pretend to know the ratios here. We're going to change my methyl to something else, just for variety's sake. And we'll do one pentyl, 2 isopropyl, oops, one word, cyclohexane. And we're going to make sure the groups are on the same side. So how do we say that? Same side of the ring. Pause. He talked about same side of ring the other day with nomenclature, and I think he was talking about cis and trans, and he wants these on the same side of the ring. That's cis. He even said that should be italicized, but he'd never grade that. I can't even do it there, so there you go. I won't even do it here. And and those are the molecules we're going to draw. Cis, well, molecule in its two chair conformations is what I'm going to draw. So we followed all the steps. We haven't drawn a proper pentyl. When groups get bigger than methyl, you want to be going to sticks always. I would have been fine with a stick for your methyl group. Just put a stick and end it. It's a methyl, right? Pentyl's got 5 carbons. We've already drawn one. Here's the other 4. 1, 2, 3, 4. 1, 2, 3, 4. Oops, 5. Always verify you've got the right number. 1, 2, 3, 4, 5. So I've got my pentyl on 1, and isopropyl has to go on 2. Now, which of these words do you think refers to cis or trans? Is it the upward or the axial word? And we didn't need to know axial versus equatorial the other day to do cis and trans. Same side of the ring means if one of the groups is up, then the other group is also up. So you go to carbon 2 because the name says you have to go to carbon 2. You're going to put an isopropyl. But remember the way we drew the chair, all the steps in order. What bond did you put on first, the axial or equatorial? Because on carbon 1 and 2, in this question on your exam, I want to see all 4 bonds. I do not want to see every axial in this molecule. I do not want to see every equatorial in this molecule. In this particular question, I only care about carbon 1 and 2. If my molecule had 1 and 3 in its name, I only need to see all of the bonds on 1 and 3. And I'm going to answer that question I started by saying that the next bond you draw on 2 must be axial because that is the one that follows the carbon angle. So I'm drawing the axial. I don't know if there's an H on there or an isopropyl. I'm drawing the bond. And I'm going to try a little better to draw it straight down because it's axial, straight down. How do we know axial straight down again? And that's not a very good straight down either. Because the carbon angle points down. Carbon 2, this angle points up. The axial has to point up. Axial means straight up. I'm having trouble with straight up, aren't I? Computers sometimes get us out of pickles. There. And then you draw equatorial. Equatorial, if this was straight down, equatorial is slightly up. Remember, every carbon has an up bond and a down bond. If you draw both your equatorial and your axial down, it is wrong. If you draw both of them up, it is wrong. One must be up, one must be down. You clearly drew this bond down. Equatorial is slightly up, parallel to not this bond, but this bond. Parallel to not this bond, but this bond. And they are already parallel to each other. Here we go. I did my best. Let's see how parallel it is. Not bad. Okay, notice I haven't put any groups on there yet. Carbon 2, I've got the axial because I always do that first. Now my question for you is equatorial like this? And the answer is no. I know it's down, but it is not parallel to this or this. You chose the wrong direction. It is this one. Parallel to that and parallel to that. Now we go back to our cis-trans. Cis means the two groups in the name are on the same side. You already chose to draw your pentyl up. You could have drawn it down, but you did not. You drew it up. This is totally your decision until now. You have no more executive decisions available to you. When you choose up in a molecule that has to be cis, the next group better be up. Which of these two bonds is up? Answer this one, because this one's down. Please put the group on and the H. Isopropyl is a V. It's not a very good looking V, is it? And H. Do not leave a bare stick there on carbon 2. There is no methyl in the name. Okay, I see it a lot. It's going to happen. I try to be a little lenient, but if you're doing it all over the place, I got to take points. When you go from one chair to the other, what stays the same? What changes? Here's a reminder. The up pentyl is still up. The axial pentyl is now equatorial. The up isopropyl is equatorial. I'm going to use the short form EQ. On the test, it says you can do that anyway. And it better be axial and up here. Don't forget to put your isopropyl there. And your H there. H stayed down, didn't it? H down, isopropyl up, equatorial becomes axial. Move on to carbon 1 or move back to carbon 1. Pentyl's up, it stays up. Axial pentyl becomes equatorial pentyl. It's good. Now the remainder in this question, and it's a 12-point question. It's not to be laughed at. So far you've got 7 points. 8 points. You got 3 each for the 2 chairs drawn properly. You got a half point for telling me this is axial and half point for this is equatorial, half here, half there. We're at 8 points. Got 4 to go. One quick point is to circle the chair that's the more stable conformation. You're going to go and do that. Circle the chair that's the more stable conformation, and you don't know exactly why I'm circling this one. But I'm going to tell you why. Remember, if you're a bigger group, in fact, bigger is not the right word either. We should be using the word bulkier. The bulkier, bulky group needs to be equatorial. We'll talk about what bulky is, because in this case, the bigger group is actually the least bulky group. Okay, why is an isopropyl bulkier than a pentyl? Well, the isopropyl, the carbon attached to the ring, has 2 methyls on it, 2 carbons. The pentyl has only 1 carbon. You can swing that carbon away from the axial H's that are here and here. Remember, the ones that are 2 away are the bad ones? So this carbon is not close to this H here or this H here. You swung it away. You try doing the same with this thing. Swing one, you're over here though. When it's axial is when it's important, right? You swing one of them away from the ring, but then the other's in towards the ring. You can't swing both of them away from the ring. That means there's going to be more steric hindrance on this bulkier group. So bulkier group is branched close to the ring, and people always ask me, what does bulky mean? The bulkier group is branched closest. Hello. Wow. It turned off. It's tired. To the ring. And your explanation of why you did your circle were 3 points. Got 2 minutes. Explanation, 3 points. Explain circle, 3 points. I'll put it, type it. Here we go. You got to have bulky in your answer. You have to have the magic words that I promised earlier worth 2 points. 1,3 diaxial repulsion. The bulkier, I had the same typo before too. Bulkier isopropyl group avoids 1,3 diaxial repulsion. All of that gets you 3 points. All right. And make it baby blue. And that was what I wanted to talk about today. So there's your explain. This is a 12-point question. And I hope you found this discussion useful. And we're going to pick up by finishing chapter 2 on, what day is today? Wednesday? On Monday. So please have chapter 2 completely read by Monday. Try to catch up on all the owls in chapter 1 for sure, and everything up to chairs in chapter 2. And that is the best use of OWL if you can do that. Get them caught up before Monday, and that way you're on top of lecture material, and that's the best use of OWL. Do it as soon as you're able to with the lecture material. And with that, I bid you adieu, and I will see you on Monday.